Good evening, everyone. So, welcome to the course on Introduction to Multimodal Urban Transportation Systems. So, the course instructor is Dr. Kupal Goswami from IIT Kharagpur, and this is interactive session week 1. So, it is conducted by me. I am a research scholar from IIT Kharagpur. So, the focus and agenda of conducting these weekly interactive sessions is to bridge the gap of interaction in online learning. So usually what happens in any course that is offered worldwide, so there are less interaction between faculty or the course instructor and the students, right? So because of that, there are many disadvantages, right? So to bridge this gap, this session has been organized by NPTEL, right? So this will be a problem solving as well as doubt clearing sessions, where the numerical problems will be solved initially by step, and then for the theoretical questions, first students can participate by answering, by giving the correct answer in the chat box, and then I will explain the correct answers later on. Right? So then also he or she can ask any questions or doubt that is there uh, in the course itself for that particular week. So then let's start. So I have designed a total of 8 questions for this week 1 session. So now let's start. So the first question is, rapid growth of urban areas is resulting from, right? So there are 3 options. First is development of transport and communications. So second one is increase in population and migration from rural areas, and third one is educational and recreational facilities. So the correct answer would be B, which is the increase in population is and the migration from rural areas in search of jobs. Right? So these two factors are basically responsible for the rapid growth of urban areas. Right? And after then as the rapid growth has been seen in the urban areas, so there is a need to develop a transport and good transport and communication network, right? So it is not the other way around. So as there is a there are population has been increasing and their demand is increasing and they are staying within that particular area, so now there is a need to there is a need to develop a good transport and communication, right? And as there are population as there are population increase in population and migration from the rural areas into the urban areas, so there is also a need uh, to establish a good educational and recreational facilities. So the primary purpose of the migration is not the educational or recreational facilities or to enjoy them. That may be occasional thing for recreational purpose, but the main point is to in search of good jobs, right? So because urban area which are having good jobs, they are basically driving the economy further. So the correct answer would be in this case be B, right? So then the next one is, what is the primary problem with motorization? So anyway, whether it is a rural area or it's an urban area, so there are basically the motorization is increasing, right? But the what is the primary problem associated with the motorization? So is it only the increasing in number of vehicles? Because number of vehicles are also increasing in the rural areas also, like as time passes. The second option is the higher concentration of vehicles in few areas. So like in a urban area, so there are this number of vehicles are increasing exponential compared to any other rural area, I would say. So if it is so, so the here also the correct answer would be B, right? So higher concentration of vehicles in few areas, that is metropolitan cities or major urban areas, because people are coming and staying there. So there is the concentration of vehicles are increasing there. So now as this vehicle concentration is increasing, so it will actually create congestion on roads, and because of this negative congestion cost associated with this higher concentration of vehicles in these areas, so it is negatively impacting the economy, because if, as you know, that transport is directly affecting the GDP of a country, right? And then the decrease in employment opportunity. So it cannot be directly said that because of the motorization there is a decrease in employment opportunity, but if a city is so much congested and a metropolitan city, that it is very difficult for people to go from one point to another using public transport. So as you know that poor people are always using public transport, and if there are too much of motorization and there is a less public transport which runs on the roads, then their employment opportunity reduces. So in that aspect, so it is not a primary problem. So the primary problem is this. I hope it is clear. So then the third question is, a mathematical model can be defined as. So the first option is physical representation of reality. So actually what physical representation of reality means is, actually it's this option corresponding to a physical model, right? It is not a mathematical model if it is a physical representation of the reality. So suppose we made statues on the road, right? So that can be a physical representation of the reality. But in case of engineering point of view, uh, like there are wind tunnels, right? In the research institution you will find the wind tunnel. So if it is so, so then wind tunnel, why this is used? So this is used to replicate the situation uh, which actually are facing the tall buildings. So if there is a tall building around 10 meters of height or more than 10 meters of height, so there will be a additional wind load coming from any direction to the building. So when you design a particular building, you need to consider that load also, right? So then this wind tunnel will be used and can be used to then you made a model of a building and then use the wind tunnel to basically replicate that scenario, and then accordingly you can design also, right? So and also there are some so there are basically, so whoever is joined, so I am describing this mathematical model, right? There are four options, so I will describe each of this. So first is physical representation of the reality. So basically physical representation of the reality means it's not a mathematical model, it's a physical model of the reality. So here physical model means, so if you made a statue of a person, famous person, so that can be also a kind of model, physical representation of reality. But in case of engineering point of view, it is not a statue, but if you see, if you are background for civil and if you are from structural engineering point of view, so there are wind tunnels on the colleges, right? Research institute, they have wind tunnels. So now if they have wind tunnel, so they can replicate the scenarios of tall building facing the wind loads from both sides, right? And accordingly they can design the safe structure. So it is the physical representation of the reality. We are mimicking the tall building in the lab, right? So that's the physical model. Second one is the representation complex reaction with the help of symbol. So here if we know that specifically in case of computer intelligence, so we know the what is a flow chart, right? So as computer doesn't understand beyond 0 and 1, that is binary, so we kind of made a flowchart so that computer does understand those things, right? So that kind of thing is called as this B can be associated with this kind of symbolic model, right? So it can be said as a symbolic model. Third one is using variables, parameter and equations to represent complex relation. So it is actually the mathematical model. So why? So there may be variables like x and y. X could be an independent variable, y could be a dependent variable, and there is equation like, so simple regression equation is y equal to mx plus c, which is a linear equation. Right? So this is a particular mathematical model. It can be linear, it can be non-linear, but the correct answer here would be C. Right? Now fourth one also we shall discuss, which is the representation of simulation for device structure. So here what we do, we use computer simulation and we kind of use simultaneous mathematical models, not one but a group of models to represent a kind of physical scenario, right? So that can be considered as a simulation, computer simulation model, using at the background they are also using the mathematical thing, right? So fourth question is what does this red line represents in the graph below? So whoever the participant is, he can try to answer if he wants in the chat box, right? So you can answer this in the chat box, and then maybe I will start explaining. So what does this red line represents in the graph below? Is it a supply curve? Is it a demand curve? Is it a surplus? Is it subsidy? So maybe I shall discuss, right? So if you consider this red line is a supply curve and this green line is a demand curve. Now let's understand the curve itself. So as you can see in the y, it is cost or price of a certain commodity, and the x, it is volume or quantity of the things. So suppose the price of a certain commodity like a petrol or something is very high. Right? So obviously if the price is high, then the consumer will not be willing to buy that item. Right? So the demand will be automatically less. Right? And the vice versa, the opposite also is true, right? So then if you consider the perspective of a supplier who is supplying or the item, so if he increases the supply of a particular item, so the supplier what he wants, basically he wants profit, so he want to increase the price of an item, and then he will supply more, right? So they will supply those items more. So then if you see the curve is this. So as the price increases, also the supply increases, right? But this is the opposite thing, right? Also because although this red line represents the supply curve, so it would be the correct option for this. But we shall discuss also the what is surplus and subsidy also, right? So here what happens at the exact this point, so this price we can say the whatever the demand is, so this is the demand curve, this is the supply curve, right, what I have discussed here. So it is coinciding in this exact point, so right. So now for a particular market the supply and demand are equal. So what the consumer is willing to buy is equal to the supplier who is willing to supply those number of items at certain price. So this price is equilibrium price. So here both supplier and the consumer are satisfied. So then what is surplus? So if you have if you have a surplus of some certain items and your demand is low, then it's a surplus situation. So in this situation what the supplier wants, supplier wants to sell those items, right? So then he needs to decrease his price, right? So this is surplus. And then what is subsidy? So suppose you have a so suppose it is a equilibrium cost, right, for a demand curve. So now if you want to if you want to make like here the consumer is satisfied, right? But if the supplier wants that I will sell more items, so he needs to decrease the price, right, in order to catch those customers. So then what he or she can do is to provide some kind of subsidy. So subsidy concept is like, suppose you are in a public transport, right? So now the fare of this public transport suppose is 20. So if certain operator or government gives subsidy of 10 rupees, and now the price of a particular fare is 10 rupees only, so there will be more people which will be availing the service, right? So that extra people who are availing the service, they are basically called the latent demand or latent demand of consumers. So this is subsidy concept. So if you have any queries also, you can ask in between. That is also not a problem, because since it's an interactive thing. So then the fifth question is, arrange the 4-stage modeling in correct order. So I want you people to try first, then maybe I will explain each points and also what is the correct option. So you can answer in the chat box. Anything you can answer if you know, and also if you doesn't know, that is also okay. You can answer. You can attempt at least, so that we can interact. I am audible, right? I think. Okay. So you guys can try to answer. So is it starting with what? Trip generation or assignment or model split or trip distribution? B. Okay. So actually it is B, right? So you are correct. So so maybe I should discuss each of the steps of this. So then this is a modeling process, demand modeling. So in case of any transportation problem or any transportation planner, he wants to forecast the what are the needs. Like today suppose you have a road network, so now if you need to forecast that what would be the requirement of roads after maybe next 5 years, how should we plan to accommodate those extra vehicles and all, so that you need an estimate. So in that purpose you need a demand kind of estimation of demand. So for that purpose, so there is a this 4-stage demand modeling basically transportation people are using, right? So first is you collect data before you come to any trip generation or thing. First you collect data, socio-economic data, then what is the existing demand data, that is number of vehicles are flying on the different roads. So after you collect those kinds of data, you divide it like if you have a region, you can divide it into small zones, right? That is called traffic analysis zones, TAZ. So now if you have some multiple 3, 4, 5, 6, whatever the number of zones are, so for each zone, you based on the data, you need to calculate that what is the number of trips that a particular zone is generating, and what is the number of trips that a particular zone is attracting from other zones, right? So because if a area is an industrial area, then it will obviously attract more trips than a shopping area, right? If you have a zone around a shopping area, so like that. So then what you can do, you need to do a trip distribution. So trip, now you know what are the trips that is produced in a zone, as well as what are the trips that is attracted by that zone, right? So now what you need to distribute those trips. So how do you know that which are the trips that is going to which region, right? So one of the famous models is gravity models. So what gravity model does, it uses some kind of impedance or metric. So it can be travel cost, it can be travel distance, it can be anything, any other transportation impedance indicators. So suppose why it is needed, suppose you have two zones, three zones A, B and C. Suppose your distance from A to B is lesser than your distance from A to C. So then your population of B is less than your population in the C zone. If it is that, so there will be more trips in A to C, but your distance is less between A to B, the distance is less, but still there will be more trips between A to C because of the population. So this kind of thing gravity model does. So then the third option is, now you know the trips are generating and trips are going. Now you know what mode to choose, right? It will depend on many factors. So like they are using utility mode. So suppose for A to B, we know A to B and A to C, this number of trips are occurring, right? So now we need to know which are the modes that are available. Suppose there are cycles and auto rickshaw are available for a particular, and maybe two-wheelers are available. So by comparing the utility values of these three distinct modes, we can say that which are the modes that particular direction may be it will use, right? So how this utility has been calculated? This utility can be calculated by considering the generalized cost of travel. So if for a particular if the distance is less but your travel time is more, so it will negatively impact that cost value, right? It will increase the cost. On the other way, if you are going using a public transport, or you need a transfer, right? So it is not a single journey, but you need a transfer in between a point, like you need to change your bus. So that will also put a negative, like higher cost to that problem. So in that way, it will try to see which are the modes that it will use. So then after you know the mode also, then you want to know the path, right? So for a particular trip, which path it will follow. So suppose you want to go from A to F. So you can go through A, B, C, D, E, F, and you can go to A, then G to F. So maybe your travel distance between A to G and F may be less. Maybe your travel distance between A, B, C, D, A through B, C, A to F through B, C, D, E is more. But that depends on the factor that how to choose it. So what what route they will use, right? So there is a model called all or nothing assignment model in transportation modeling. So in that model, actually based on travel distance, you will find the shortest route based on not only travel distance but maybe also the travel time, because those may not be same, the travel distance and travel time. So so that's how it will start from trip generation and it will ends in route assignments or trip assignment. So then the question is, vehicular emission do not depend on. So vehicular emission do not depend on which of these factors. So first you can try. Is it vehicular speed, or is it age of the vehicle, or is it weather, or is it vehicle kilometers? That is how many kilometers a vehicle is traveling. So vehicular emission do not depend on which factor. Yes, the answer is C, because vehicular speed, if you have two vehicles, uh, two same power by weight ratio vehicles, so that their engine capacity and all the things are same. So if one is using uniformly, going uniformly, suppose one is traveling in the morning and one is traveling in the congestion, so their speed profiles are different, right? Because in the morning maybe it will go at a constant speed of 50 or 60 depending on the type of road, right? But if it is going in peak, during peak, like in the morning 9 to 11 and in between, for a particular stretch of road, so uh, it will face, like the speed profile is different, and speed profile is, it will be not uniform, it will be rough, and based on that it will emit more gases, right? So then the age of vehicle. So as you know, already in India also the rule came that I think if it is a commercial vehicle and if it is older than 15 years, so you should you are not allowed to use that vehicle, right? So already those things are came. So as the vehicle ages, so its engine emits more due to its nature, and uh, it is basically vehicle emission will be dependent on the age of the vehicle, right? And then vehicle kilometers, so as you can travel more, so if you travel more, your emission will be more. And then weather, so basically here vehicular emission means tailpipe emissions, right? So whatever the emissions are getting from the tailpipe of that particular vehicle, so in that case weather has no effect, other than sometimes in winter there is a, like a cold start problem is there, but that we can neglect because that is negligible. So then the answer would be C, whether it is not depending on weather, vehicular emissions. So then what are the factors that are affecting quality of service? So then what is quality of service? So quality of service is based on a traveler's experience, how good a service is, right? So if you are traveling by a bus, right? So how based on your perceived experience, how is the quality of that particular bus service, right? So suppose travel time. So if travel time is more, then you would rate it as not that good, right? But if you feel that okay, it's a reasonable travel time, there are less congestion, so uh, your your perception about that service will change, right? So it will obviously depend on travel time, and travel time and travel speed is directly related, right? So if your travel speed of the bus is faster, then your travel time will be less, right? So it is directly dependent on it. And delay, so as you know, so if your travel time is faster, so then you are facing less delay also, right? So A surely is the these three factors will be affecting the quality of service, right? So then comfort. So what is comfort? Comfort means if you are riding a bus, then if the bus is less congested, so there are it is not overcrowded, I am saying. So and you have a, at least you have a set, so you have a like you are sitting. It is not that you are standing. It is then you can rate it as comfort, right? Then what is convenience? So convenience is, suppose you are going from a point A to point B, right? So then you need to transfer in between. So then it is not convenient for you for by using that bus service to go from point A to point B by getting two transfers. So another way would be like if you have a smart card, which you can see in many developed countries in the US and in many cities in the Europe. So they have some some one card that you can use for any mode, whether it is bus, whether it is means public transport mode obviously, whether it is bus, whether it is metro, whether it is light rail transit, so you can use the same card. So it is very convenient for the from the user point of view, right? So this is the difference between comfort and convenience, and both are affecting the quality of service since it is the experience of the traveler. So then safety, obviously, uh, there are also two kinds of safety. So one is pickpocketing kind of scenario, which usually happens in many of the cities in India. Many of the cities, not all, but some cities are experiencing. So then also it will degrade the level of service. So you want a safe ride in terms of that pickpocketing thing, and also it should be accident free also. So if at a certain stage there are frequently accidental occurring, you will also not feel safe to travel, whether it will be a bus or whether it will be any other mode of transport. So then also maybe sometimes buses are like rash driving scenarios are also you can observe in many of the Indian cities. So that is also uh, can one of the safety aspects, and then the user cost. So based on that, we can see the user cost also, right? So user cost in terms of what I already mentioned, that it could be the transfer, it could be the travel time, it could be the comfort, it could be convenience, it could be everything, right? So it's a generalized cost of travel, including the benefits also. So these are also the factors which are affecting the quality of service. Then the availability of information about the services. So it is like the apps which are there in the in case of buses or metro, there are apps, right? In case of IRCTC app also, it is saying that buses are coming. So if the app is good, if its accuracy is good, then also it is like you can reliable you can rely on that particular service. So it is also making a traveler attract towards that particular service. So in this case, the correct answer would be answer D. So these are the things also that I was mentioning. So then what is the level of service for signal control intersections? So now just we looked at the quality of service. So level of service is nothing but the stratification, quantitative stratification, right? So level of service, uh, if you see the highway capacity manual, which is a manual developed for transportation engineers, so their level of service category is A to F, and it is based on a particular performance measures and its values. So like if you have density, then density value, if it is this to this, then your level of service is A. If your density is more, then your level of service is bad. The density is less, then your level of service is more. It's like that. So then for signal control intersection, what is the level of service? So for different facilities, our level of service measures are different, right? So first one is density. So what is density in traffic point of view? So if there are certain number of vehicles, like number of vehicles that is occurring along a unit road length at a particular time. So suppose at a particular instance, you will find that in 1 kilometer of road stage there are 90 vehicles. So 90 vehicles per kilometer is our density, right? So as density will be more, the congestion will be higher. Right? So now for signalized intersection, also if you see how to choose the LOS performance indicator. So it should be the perspective of the traveler, and it also has to be useful to the operators as well, right? So now if you see a signalized intersection when a particular vehicle is going and the traveler is stopping at red, and then when is the green is there, then you can go through the intersection. So is it density that the traveler is facing there? Because in the morning also, even if there are less number of vehicles, you need to wait at that red signal. That time your density will not be very much, right? Your density will be very less, maybe 3, 4, 5 or couple of vehicles will be there around, right? So it is not affecting the maneuverability, right? So you can easily move your vehicles, right? in that scenario. So it is not the density in case of signalized intersection which is governing the level of service, right? So is it V by C ratio? So what is V by C? V is volume. So at a particular time, say 9 to 9:15, within that 15 minutes, what is your volume? And what is your capacity? Capacity is what? Capacity is maximum number of vehicles that can cross a particular section in 1 hour. So that is our capacity. It is also kindly related to the congestion, right? So it is also not governing our LOS for case of signalized intersection, because as a driver, because or whoever is driving the vehicles or whoever is sits on the vehicle, he is not experiencing this V by C directly, right? It is not his perception, he is not able to experience it. So it is also not the LOS for signalized intersection. So then what is speed? So in case of signalized intersection, if you are stopping at that particular intersection, so there the speed will be 0, right? So there is, it is also not a direct, it is not directly affecting the LOS. So then the control delay. So what is this control delay? So it is governing the LOS. So actually at a particular intersection, what you are experiencing is the delay, because for that signal you have to wait, so your travel time increases, that is, it is basically the delay. So here it is particularly the control delay. So the control delay is the summation of uniform delay, incremental delay and initial Q delay. Although it is not a traffic engineering course, but maybe for better understanding I will be slightly explaining this to you, right? So what is uniform delay? So suppose in the morning there are less vehicles are coming, like for a particular 1 hour maybe 200 vehicles are coming per hour, right? So then the uniform rate of arrival, it is not that every 5 minutes the rate is changing, somewhere it is 1200, then it is 14, then it is 2. It is not that kind of graph, it is like a simple graph that 1200 vehicles are coming in an hour, right? So then whatever the delay is, that is called the uniform delay, because the rate is uniform. And obviously the assumption is this undersaturated condition exists. So in that 1 hour, whatever the vehicles are arriving in that intersection and whatever the capacity is intersection, right? Capacity of that intersection. So the capacity will be way higher than the demand. So easily the intersection can handle those vehicles which are basically passing through the road, right? So then what is the random delay? So the random delay is, suppose you have a for 15 minutes interval of your time period, but your cycle length for a particular signal is 60 seconds, right? So there will be many cycles within that 15-minute analysis period, right? So then your overall, if you see the 15-minute analysis period, suppose your capacity is 2000 vehicles per hour within that 15 minutes period, and your vehicle arrival is only 100, so it can easily account for the capacity can easily intersection has the ability to use that to apply that vehicles, right? So then also for some cycles, because of the random interval, so the vehicles are not usually not coming, they are not coming uniformly, right? So they are coming randomly. So what is random? Random means if for a particular 1 minute 5 number of vehicles are coming, then in the next minute maybe some 10 vehicles may come, then the 15, 22, it's a random thing, right? So for a particular cycle, it may happen that the vehicle capacity is exceeding the demand is exceeding the capacity. So to account for that delay, it is the random delay, right? So then what is overflow delay? Overflow is if it is within the 15-minute analysis period, each of the cycle is oversaturated. Therefore, every cycle there is a demand is higher than the capacity. So it is called the overflow delay. Then what is initial Q delay then? So if you have two 15 minutes analysis period, so your total analysis period is half an hour, so you divide it into 15 and 15. So if after the 15-minute analysis period you have some vehicles that are left due to oversaturated conditions, right? For 15-minute period, if your capacity is less than your demand, so there will be some vehicles that are queued up in the next analysis period and the next cycle, next first cycle of that analysis period. So to account for that delay, because this kind of scenario actually happens in during peak hour, so that is initial Q delay. So now this random and overflow will be clubbed together in case of incremental delay, what I have shared here, and then the uniform delay and initial delay. So the total is the control delay. So then here the answer would be control delay. So if you have anything to ask, not only from these questions, but also if you have something to ask based on the like this week's content, you can ask, right? Because this is primarily focusing on the interaction between. Okay. 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 Hmm. Okay. 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 That maybe I can once I can. So the first question is rapid growth of urban areas is resulting from, right? So why there is a rapid growth in urban areas? So obviously the population of India is rising, right? It is increasing. Then also the people are migrating from the rural area to urban area for basically jobs, right? Mainly jobs, because there are opportunities in jobs. So that's why people are migrating from rural to urban. So it is the main thing that is like, for this thing the population of a particular area, that is urban area, it is increasing, right? So as your population is increased in urban areas, so now there is also a need to build a good transport and communication network, right? Because your already the number of people is being rising that are living in that urban area, right? And it is not for educational and recreation facilities that people are migrating, because for recreational I may visit once in a month, once in a year, depending on the distance, and then I can come back, right? It is not necessary for a particular person to stay, right? Because of the jobs, people are mainly going to the urban area. And as it's a urban area and the number of people and populations are more now, so you need to build good infrastructure in terms of educational institution also, you need to build, right? So it's the other way around. So this is the correct answer: increase in population and maybe migration to rural areas. So then what is the primary problem with motorization? So is it only the increase in number of vehicles? So because if you analyze the rural areas also, if you analyze 1970 and 2020, so obviously there is an increase in the motor vehicle ownership also in the rural areas, right? Some kind of you can find that two wheelers, they are also now using the two wheelers more often, right? So is it that only the number of vehicles that is the primary problem, or is it higher concentration of vehicles in some areas like in metropolitan cities in India? Those are the main focus urban areas, right? So there are basically the people are coming and their demand is increasing, and they are basically in that areas the concentration is increasing. So that is actually resulting in congestion, delay, the environmental problems, that is emission of gases. So now as you develop this kind of huge demand and those urban areas, so now you have congestion problem, right? So now you are not able to go in time from point A to B for suppose your home to your job, like your office. So like Bangalore, it is basically that city is in the news like for the congestion all the time. So like you are you are delaying the process. So now as you are delaying for your work, so your productivity decreases, right? So it is actually impacting the economy negatively. So first, so then what is the decrease in employment opportunity? So we cannot say that motorization directly decreasing your employment opportunity, but you can think it like this. Like if you have a congested road and if you are poor, right? So you have no means to travel by car. You need to travel by bus only, public transport means only, maybe bus. So now the road is congested, there are less public transport that is running on road. So now the poor people are basically are at disadvantage, right? So they are not able to going for work and those things, so it may negatively like decreasing their employment opportunity. It is not direct, but it can be thought as a indirect thing. So then I think this is you are present when I was discussing this, right? No. Okay. Oh, oh, okay. Okay. Then this question is what is mathematical model, right? So there are many models. So first they are saying that physical representation of reality. So what is physical representation of reality? It's a physical model. It's not a mathematical model. So what is a physical model? For layman understanding, you can consider a statue of a person, famous person, as a physical model, right? But for engineering perspective, suppose like if your background is for civil, and then you know the structure, so there are tall buildings, right? Generally tall buildings are subjected to wind loads also, right? Because if your structure is more than 10 meters long, the high rise buildings, so there are wind forces are occurring from both ends, right? So now you need to build a safer high rise building, right? So that it can withstand the load of that wind, right? So now the experiments has been conducted in the lab by creating a model of that kind of buildings in the lab and using the wind tunnel as a wind force to replicate the exact same scenario which may occur in the real world, right? So this is called the physical model, right? Also I being my background is civil, so I was participate in a bridge. Like generally how much like you first you make a bridge, and then like a small bridge, and using some kind of material, I don't remember the exact name of the material in my BTech days, and then you need to put the load in terms of some balls, then you see the what is the load bearing capacity, then you use the scaling factor to see like how the design is actually affecting this kind of that bridge, right? So this is called a physical model. So second one is representing complex relation with the help of symbol. So it is called a symbolic model. So what is a symbolic model? So suppose computer don't understand any algorithm, right? Computer don't understand our language, right? So if you want to make it understand, we need to use either input 0 or 1, right? Binary. That basically computer understands. So you make a flow chart consisting of 0 and 1 like that. So which actually if you have done programming also, you know how a flow chart works, right? So that's a symbolic, that's an example of a symbolic model. So then third one is using variables, parameters and equations to represent complex relations. So suppose you have a variable x which is depending on y. So if you want to, like if you can take an example of a speed along a particular road. So the speed of a vehicle is not only depending on the vehicle power by weight ratio, but also it will depending on the road geometric facilities that is provided on the road, right? So then you have two variables, x1 and x2. x1 is road characteristics, x1 is your vehicle characteristics, and x2 is your road characteristics, and y is your speed, right? And your x1 and x2 are distinct variable. They are independent. There is no relation between between the characteristics of a vehicle and the characteristics of a road, right? Those are independent. So those are independent variables, x1 and x2, and your y is a dependent variable. So your speed is depending on those factors. So now you can model it. If you find that there is a linear equation that can be used, so you may use it like a simple linear regression. So y is equal to m1x plus m2x plus c, right? C is for what? C is for any other factors which you are not directly taking, right? Because your speed may be depending on primarily those two factors. So there are many unobservable factors also, right? So in that case, externals, right? So then it's a mathematical model, right? So now the fourth one is a simulation. What is a computer simulation? So now if you want to see the variation of speed along time, that is the spatio-temporal variation of speed. So now if you have certain 1, 2, 3 mathematical models, so now you can generate one particular simulation model to replicate the scenario of changing speed along the length of the road, also the temporally along the different time frames within the day. Within the day, different times how the speed has changed. So you did a simulation model which basically comprises of maybe 2, 3, 4 complex mathematical models. So it is a simulation model, right? So then I think this has been discussed. Oh, okay. Different softwares you can use for a simulation, but actually at the who are the developers are developing is using different kind of models only, right? Suppose what is your background? If I could, okay. So I don't have that much of idea exactly which software you are using for your purpose. But if you are using some, then maybe for a vehicle, like we often use VC, there is a software, right? In case of you also, maybe there could be some another softwares. Uh, okay, so GIS, right? Okay, got it. GIS also I sometimes use. So, but computer simulation, it's like you have complex set of mathematical models combined together, right? Because it is not possible to like without simulation, without computer, you are not able to combine those things, right? So, if you want to build a simulation model, you can build one, right? Because someone is building, then we are using the software, right? Whatever the model is. So that's a simulation model. So any other queries? So I am not exactly sure, because last part there is a integration part. So maybe I will let you know in the next session, right? I need to exactly see that is it is there or not. But I don't think directly they like there may be some kind of discussions, but it is not hands-on session will not be there. I believe there. Okay, that I will let you know for sure in the next session. I need to see, then maybe in the next session we can connect, and then if that is so, then maybe I will let you know, or you can uh, you can parallel it, right? Okay, then I think we should close the session, right? Okay.